Okay, so in EIGRP route filtering using ACL, okay, we have already completed condition 1, right? In condition
Yes.
1 we have seen how to filter the incoming routes. Okay, so what was there in condition 1? You can see that R1 was receiving 4.1 and 4.2 from both ISP, but in condition you says you
Yes.
as administrator you wanted to receive 4.1 only via ISP1 but 4.2 via both ISP. So you can check here the routing table, right? 4.1 only via ISP1 and 4.2 from both ISP. Done. Okay, so as we have completed our lab number 1, condition
Yes.
number 1, now we are moving to our condition number 2. Condition number 2 is saying that by default R1 router is receiving 4.1 and 4.2 from both ISP. Okay, no problem. But you as an administrator, you want to receive 4.1 from both ISP, ISP1 and ISP2 and filter 4.2 not to receive from both ISP, right? See here
Okay.
what I have said. Here we said we want 4.1 and 4.1 via ISP1 but load balance for 4.2, right? And here we want
Yes.
4.1 from both ISP but I want to filter 4.2. Okay, okay, so no problem, we'll come here again. So if you'll, so what we have to do here, we have to remove the ACL, right? So we have to come here. Okay, no access list 10, and then we'll come here, router EIGRP 10 distribute list. Remember, so we'll come here and we'll say no distribute list and enter,
Yes.
and then we'll check here after resynchronization. Okay, so it's resynchronized. Now we are checking here. Okay, see 4.1, 4.2 we are receiving from both ISP, but as our condition we say that 4.1 I want to receive from both ISP, means 4.1 I want to receive from both ISP. Okay, but
Yes.
4.2 I want to filter it. So let's come here to create a new ACL. Okay, so I'll come here and say that access list 10, any number you, we are creating standard access list. Okay,
Okay.
okay, and now here we are saying that deny 4.4.4.2 because we said that we want to uh, filter 4.4.2 not to receive from both ISP. So we will create ACL for this one, and the wildcard mask, if you want to enable log you can create log also. Okay, and then access list 10 permit. Okay, permit any. Okay, and then we can write here router EIGRP 10 and then distribute list. Okay, distribute list ACL. Okay, now see here what you are receiving this for 2. Okay, you want to
Both
block
side.
for both ISP or a single ISP?
Single.
No, both ISP. See here what I said.
Both. Yes.
I said uh, I want to filter this 4.4.4.2 not to receive from both ISP,
Mm.
right?
Both sides.
So
Right.
when you want to receive from both ISP, so in that condition you do not have to add interface, you say just in.
Okay.
In means all
So it's like
interface.
the
Yes,
default.
Okay, and then say enter and then exit, and then exit, and just wait for the resynchronization. Okay, resynchronize from both ISP, and now you check the routing table. See, now you are not receiving 4.2, and now when you are checking here, see, earlier you were able to communicate, remember, for 4.2.
Yes. Yes.
Okay, here also you were able to ping. Now if you try to ping 4.2, no communication, right?
Yes. Unreachable.
Okay, so now see 4.2 has filtered by okay. So again same, if you want to make your lab default, so I'll say that no access list 10.
Yes.
Okay, and then router EIGRP 10, no distribute list. Okay, and then wait for synchronization. Okay, it's resynchronized, and now you check. Now your lab is default, right?
Yes.
Okay, now we are working in third condition. In third condition is saying that this is our third condition, condition number third. Okay, as per above lab, R1 has its locally connected network 1.1.1.1, 2.2.2, 10.10, 10.1 and 20, right? So if let's verify same
Yes.
according to the statement. Yes, R1 has 1, 2, 10, 1 and 21. Okay, fine, no problem. We verified this one. Okay, and you and R1 is advertising this 1, 2, 10, 20 towards EIGRP network, right?
Yes.
So if they are advertising, so if you'll come here to Google, you will see that Google is receiving 1, 2, 10 and 20, right?
Yes.
Okay, now so now come to the condition again. Now but what you want, so you as an administrator, you don't want to advertise 1 and 2 towards
Two.
ISP.
SP.
Okay, so you have to filter 1.1.1 and 2.2.2 from EIGRP update via ACL. Okay, and hand over the filtered EIGRP update to ISP1. Means you want to filter this 1.1. and 2.2.2 from update. Okay,
Okay.
no problem. Let's come here. So come to R1, simply configure access list 10, deny 1.1.1.1. Okay, deny 2.2.2. Okay, and permit the remaining traffic, permit any,
And yes.
and then router EIGRP 10 distribute list distribute list 10 and out. Simple. Okay,
Okay.
and automatically it will filter all your. Okay, just wait for resynchronization and okay, it's resynchronized. And once it is resynchronized, now see, earlier you were getting like this, right? 1 and 2, but now you are checking. See,
Yes.
you are receiving 10 and 20, but you are
And
not receiving 1 and 2,
20.
right? But 1 and 2 is here,
Okay.
no problem. Here, that is your locally connected networks, right? So 1 and 2 will be
Okay.
here because those are your locally connected. And if you check here, so IP, EIGRP topology, right? See here.
Yes, they are there.
Yes, 1 is there, 2 is there in the topology table, but if you'll come in these guys, okay, these routers you can see. So IP, EIGRP topology table. What do you think? Do those network will be here?
No, no.
No, very good. Okay, but 10, yes, you are advertising 10 and 20.
Yes.
Okay, but EIGRP, you are filtering EIGRP with the help of access list from R1.
Yes.
Okay, okay. Again, you will see here no update.
Yes.
Now let me make it default. Conf t no access list 10 router EIGRP 10 no distribute list 10 out. Okay, wait for resynchronization and then we'll check the update. The update is there now. If you are coming to Google, yes, now 1 and 2 is there. So your lab is default now. Let's come with the fourth condition. Now see fourth condition. In condition 4, okay, we'll see that by default R1 is receiving 4.1 and 4.2 from ISP 1 and 2. Okay, no problem. Yes, verify. 4.1 and 4.2 you are receiving from both ISP. Okay, 4.1 and 4.2. Okay, now what is the condition? But you as an administrator you want to receive only from 4.1 from
Yes.
ISP1 and 4.2 from ISP2. Okay,
Yes.
are you understanding? Means 4.1
Yes.
from here and 4.2 from here. Okay, means you want to block 4.2 from this side, right? And 4.1
Yes.
from this side, right? Are you understanding?
Yes.
See, by default
Yes, I see.
ISP1 is giving you 4.1.4.2, ISP2 is also giving you 4.1.4.2, but you said no, ISP1 will give
Yes.
me 4.1 only and ISP2 will give me 4.2 only. Okay,
Okay.
so let's come and see how we are enabling it. So we'll come here to R1, conf t, same access list 10, deny 4.4.4.2, and again then access list 10 permit any. Okay, 10 to see, I want to say that from ISP1 I wanted to block 10 to because 4.1 was already coming, right? So I just wanted to block 4.2. So for that we have created one as statement block 4.2. Okay, okay, now we want to block 4.1 for ISP2. So for that I'll create a new access list 20, deny 4.4.4.1, and then permit any for 20 network, 20 ACL. Okay, and then simply will come here router EIGRP 10 distribute list. See here, distribute list 10. Okay, in
Yes.
E0/1 and
Yes.
distribute
Here
list 20
we
from
have to precise now.
yes E0/2 and then exit. Both interface filtered from E0 by 1 and wait for E0 by 2 update. Okay, updated, and now you type here exit and check your routing table. Okay, see now, can you see
Yes.
ISP1 is giving you only 4.1 and ISP2 is giving you only
Four.
4.2. Okay,
Yes. So
okay. Now EIGRP route filtering using route map. Okay,
okay.
see we have multiple filtering process: route map, prefix list, access list, okay, distribute list. Okay, so in this filtering we will work only simple lab. Okay, and what is the filtering lab? All is EIGRP path manipulation. Okay, here what is your task? Filter 111 and 2.2.2 network which is on R1 not to be advertised to ISP1 and ISP2. Same thing we have done through ACL, remember,
Yes. Yes.
in
So
statement,
now the same thing with the map.
yeah, route map, same thing we did here in with the ACL, right? In condition 3,
Yes.
same thing we are going to configure via route map. Okay, so first we'll come here to Google and check that yes, Google is receiving 1 2 fine. So we'll remove our existing ACL, or if you do not, no need to remove also if you want to create, because this ACL is totally different. Okay, this ACL is
Okay.
your outbound ACL, right? And this is route map ACL. So if
Okay.
you want, you can keep your this ACL as well, and you can create new one. So no problem. See how to create that one. Conf P, we have to create ACL. So we have to write here access list. We'll say that 50 new ACL 50. You want to deny 1.1.1.1 and we want to deny 2.2, 2.2.2.2, and then access list 50 permit in remaining traffic. Okay, and then we'll see, okay, route map. Then we'll write here route map your name. Okay, AMANDOU, right?
Yes. No, there is no N.
Okay, Amadu. Okay, and then you create enter here. Then you write here match IP address. So this is not IP address, this is your access list number. So you write here access list number.
Yes.
Okay, then type here exit. Okay, and then you write here router EIGRP 10 distribute list. Then you write here, let me put question mark here and show. See, distribute list, what we can use. We can filter via ACL. Okay,
Yes.
so we have two type of ACL, remember, name ACL and number ACL. So this is
Yes.
name
Yes.
ACL and this is number ACL. Okay,
Okay.
we can filter via
Okay.
gateway, we can filter via prefix. Okay, we
Prefix.
can filter via
Route
route
map,
map. Okay,
which we
so
are about to
prefix we
do.
will check after route map. Okay,
Okay.
route map and your name of your route map, distribute list, route map and the name of your route map. So this is the name of your route map. Okay, and you want to filter out, right? Outbound, remember you have only
Yeah.
two options, you put question mark out or in. So of course I want to filter via outbound interface, so I will say here out and then exit. Okay, exit and just wait for resynchronization. Okay, so it's resynchronized, and after that if you're coming here to Google and check, see, 1 10 is there, 20 is there, but no 1 and 2, right?
Yes.
And your existing ACL is also working, see, no problem, because we have created a different access list number, right? Okay, so prefix list I think it's not there, but no problem, when I will update I will let you know. Okay.
Okay.
Okay. Okay,
I
now
hope
we
we
are
will
work.
finish today.
Yes, EIGRP I'll finish today.
Okay.
Okay, now we are working with EIGRP stuck in active.
Okay.
Okay, so do you have any idea of EIGRP stuck in active? Have you heard about this thing before?
Yes, I think so. I think so.
Okay, see what is happening. As we know that EIGRP had two type of path information. One is successor and second one is feasible successor, right?
Yes.
Successor means primary path and feasible successor means backup path, right?
Yes.
Now, so if the successor link is down, immediately EIGRP switch over to the backup path and your communication will work easily, no problem in that, right?
Okay.
Okay. So, however, if uh, there is some topology, maybe, see, in some topology you will find that yes, you will have successor and feasible successor both, right? Okay, can you see see here?
Yes.
Okay, now tell me in this lab, uh, how many successor you have here on R1
Two.
towards 4
Oh,
dot this network?
yes.
Two successor, that's why
Physical
it is
successor.
load balancing, right?
Yeah.
But
Yes.
maybe
Yes.
some lab you will find, right, if it is 5
Yeah.
mbps, right? If
Yes.
you check 5
Only one
mbps,
successor.
so one successor and second one is feasible successor, right?
Yes.
But maybe some lab you will find that, like according to this lab, okay, let me show you. According to this lab, see, you have single path, right, towards this, right?
Yes.
So you have single successor,
Yes.
right? Okay. So here is talking here, in this lab, um, that there is some topology that has no feasible successor, right? In that case, EIGRP speaking router does send the query message to its neighbor asking for an alternate path to reach that network, right? If any network is failed,
Yes.
right, and there is no any feasible successor, so EIGRP speaking router will send query message. Okay,
Yes.
but if they you have feasible successor, means if router have feasible successor, router will never generate query message. Query message will be generated only if they do not have feasible successor. Okay, and in that query message they will be asking about that network which has down, about, okay, please, this network is down, do you know how to reach to that network? So okay,
Yes.
now, and till then, the route, which route, the route which was down, will be placed in an active route state in the topology table here. See,
Yes.
so IP EIGRP topology here. You'll find here that it is in active state something message. Okay.
Yes.
Okay. Now you will see that going to active for route, you will see one message. Okay, going for active for this route, when an EIGRP speaking router sends one or more query message to its neighbor in an attempt to find an alternate path to the network, okay, to a network that is not longer available. Okay,
Available.
so he's sending some kind of query message, right? Now see, so those query and reply we will understand here. Okay, now see what we are understanding. In the below image 1, router 1 has lost the route for 192.168.10.0/24 network. Okay, this network. So when router 1 has lost connection towards this network, right? And you can see that
Yes.
towards this network there was only single successor, right? No multiple path, right? So
Yes.
if router 1 will have only single path, no feasible successor, and that network is down, then now see, after that router 1 will look for an alternate path to reach 10.10 10 192.168.10.0/24 network. If there will be no feasible successor, router 1, if network is down, router 1 will check for feasible successor. If no feasible successor, then what router 1 is doing, router 1 will mark this 10.0 network as an active route in the topology table. Yes, okay, we will see that one. And will send a query message to all its neighbor asking for an alternate path to reach 10.0 network.
Okay.
Okay, and router 1 will also enable SIA timer, a stuck inactive timer.
Okay.
Okay, stuck inactive timer. One second. Okay, and SIA timer. And why they are using this SIA timer now? See, SIA timer is there. Like if I have sent you some query, right?
Okay.
Okay, so I am expecting some reply from you, right?
Yes.
Okay, same in like hello, if I sent you some hello message, then automatically I enable one hold down timer, and hold down timer is
Yes.
15 seconds. And within that hold down timer, if you will not reply me with the hello message, then what I will think that you my neighbor is down, right?
Yes.
So here also, when R1 will send some query message to all its neighbors, see, R1 has sent one query message to R2. R2 will also send query message to his neighbors. Okay, R1 has sent to R3. R3 has also sent the query message to its neighbor. R1 will enable one SIA waiting timer. So R2 will also enable one SIA waiting timer. R3 will also enable one SIA waiting timer, and that is 180 seconds, right? Okay, and
Yes.
if neighbor will not reply me, right? Are you understanding? If neighbor will not reply me, then what I will do? Yes, if neighbor is not replying me,
Yes. Means that
yes,
the
it
neighbor
means my neighbor
is
is
not
not
active.
active, so I will
It's
break
not
the
active.
relation and then I will
Yes.
reform my EIGRP relation with them.
Yes.
Okay, but this is a problem, right? Because it's in a big network. Okay, router cannot like break the relation, rebuild, break the relation, rebuild, break the relation, rebuild, right?
Yes.
So your network is not a stable network, but people say that EIGRP is very stable network, right?
Yes.
Okay, okay. Now let's move to second scenario. In second message, in the below message, below image, sorry. Okay, maybe, see here, after receiving query packet from R1, after receiving query packet from R1, R2 and
Yes.
R3 will reply the query acknowledgement in response to the received query packet, right? So if R1 has
Yes.
sent query, okay, to R2, and this one, like this one, okay, so R4 has replied query acknowledgement to R2, so okay, no problem. Then R2 replied to R1, same here like that, okay. Then now see, then when you will reply, I will think that yes, my neighbor is alive, right?
Yes.
Okay. Now see, after receiving this query acknowledgement means R2 is saying that I received your query, but R2 is not saying that I know about this network, right?
Yes.
R2 is saying this, I received your query, let me work on that. Okay. But see here, but R1 is still waiting for query reply, not query acknowledgement. Are you understanding?
Yes.
So
Yes.
still his 180 second SIA timer is running, but that is
Okay.
very fast. Okay, the query
Too long.
acknowledgement query, but okay, but this timer is running. Okay, now let's move in the third image. Now as R1 is waiting for 180 seconds to get it the query reply packet, right, from R1,
Yes.
R2 and R3, right, means R1 is waiting for 180 seconds to receive the query packet, query reply packet. But if R1 would not get the query reply packet within half SIA timer, means half SIA timer means 90 seconds, right?
Yes.
Which is 90 seconds. Now again R1 will resend a new packet, okay, to R2 and R3 as a SIA query. So again R1 will send to R2 and R3 also. So here I'm just showing with one, okay. So R1 will send to R2 saying that, please my friend, I have sent you one SIA query and you have replied me earlier that
Mm.
you received my SIA query packet. Remember? See here. You have
Yes.
replied me with the query acknowledgement that you have received my query packet and I am waiting for my SIA timer. Okay. Please, are you working on my SIA query packet? So R2 will say that same thing to R4, that my friend, I have forwarded one packet to you. Okay, query packet, SIA query. Okay, are you working on that? Okay, so R4 will say yes. Okay, then R2 will tell to R1 that yes, I am working on that. Please wait for your timer 180 seconds. Okay,
Okay.
now after that R2 and R3 will again reply to R1 as SIA reply. Okay, SIA reply means yes, I am working on your query. Please wait. Okay,
Good.
yeah,
Yes.
in response of SIA query, saying that I am working on your query. Okay, once R1 will get positive or negative SIA reply, means yes, I'm working on your SIA query, means this is what this is, yes I'm working means yes, is a negative or positive whatever, okay, means I'm working on that in response of SIA query. So R1 will reset the SIA timer. Are you understanding? Reset the SIA timer again
Yes.
back to 180 seconds,
Up.
means see, earlier it was 180 seconds, but after 90 seconds I have resent the SIA query, means R1 has to wait only 90 seconds, then it will break the relationship with the neighbors if R1 will not get any positive response, right, towards this network. Are you understanding?
Yes.
So again, if R2 will send SIA reply against SIA query, okay, Then this timer
Yes.
will again back to 180 seconds. Then again R1 will wait. Again R1 will, when the timer second will remaining 90, then again it will send a SIA query. My friend, I have sent you SIA, sorry,
Yeah,
one
I'm
query
still
regarding
waiting.
this network. Please, are you working on that? Then again he will send like that R2. Then again this timer will become 180. Then, but how long this process will run? Are you understanding?
Okay.
Unnecessary R1, R2, R3, all these routers are consuming bandwidth in the network, right?
Sure.
So now see, in the below image 4, now see, understand. After waiting 90 seconds, R1 will again send a new packet
Okay.
to R2 and R3 as a SIA query asking, I have sent you one query packet, but I haven't received any reply. Okay, are you still working on that previous query? After that, R2 and R3 will again reply R1 to R1 as SIA reply packet in response of SIA query packet saying that yes, I am working on your query. Once R1 will get positive or negative SIA reply in response of SIA query, R1 will again reset the SIA timer back to 180 seconds. Okay. Now the problem will come here. But how long this SIA query packet will be running between R1, R2 and R1, R3? Okay. Now see. R1 will send only 4 time SIA query packets to its neighbor, means neighbor R2, R3, and R3 will send to R6, R7, and R2 will send to like this. Okay, only 4 time. Okay, means 4 time means 4 time 90 seconds, right? So multiply it now.
Yes.
This means R1 will wait for 330 seconds for SIA reply in response to SIA query. Means if R1 has sent some query, so SIA will wait, R1 will wait for SIA reply, means stuck in active reply, for 330 seconds. In that also, if R1 will not receive any reply upon the sent query, okay, the query which R1 has sent earlier, means this is the another condition. Here is saying that if I received, see, if R1 will receive any response, whether it is
Yes.
negative or positive, but R1 should get response that yes, you have received SIA query, okay,
Okay.
and you have replied it, means R2 and R3 has replied it, then R1 will wait for 330 seconds, okay. But but if R1 will not receive any reply, okay, regarding SIA query, then R1 will break the neighbor relationship with R1 and R3, okay,
Okay.
and re-establish the neighbor relationship again. But in but here it will wait only for 180 seconds, okay. And here when response was there, then in that 360 seconds. Understood? If I will receive response, then I will wait for 360 seconds. But if I'm not receiving any response from my neighbor, then I will wait for 180 seconds. Understood? Note.
Yes.
But if R1 has sent the first time query packet to its neighbor R2 and R3, but R1 did not receive any reply, in that case R1 will wait only for 180 seconds. After that, it will break the neighbor relationship between R2 and R3 and re-establish neighborship again. So here see,
Okay.
here also neighborship, new neighborship, and here also new neighborship, here
Yes.
also new neighborship. Means see, R1 is saying, my friend, I sent you query, but you did not reply to me. Here R3 will say that, my friend, I sent you one query to work on one network, but I did not received any reply from you. So it will be
Yes.
done by all your routers, because all your routers are connected to multiple neighbors, right?
Yes.
And note again, R1 will reset SIA timer only when R1 will receive any positive or negative SIA reply from neighbor. Okay, only
Okay.
this is the condition. Okay, now, but here we will come on some lab. Okay, let's see this SIA timing, SIA query in this lab. Okay,
Okay.
so let me enable one lab here because we will see some timers. SIA query packet, EIGRP SIA time. Okay, so start this lab. So see, first we'll check IP address and EIGRP neighborship.
Okay.
R1, so IP interface brief exclude unassigned. Okay, fine. IP is there. IP is also here. Fine. Okay, IP is also here. Now we are checking some IP EIGRP. Sorry, IP route EIGRP or simply route simple. Okay, no EIGRP running, right? So we'll enable EIGRP
Yes.
conf router EIGRP, then network, no auto, fine. Come here, conf router EIGRP10 network, no auto, neighborship will come up, fine. R3, conf router EIGRP10 network, no auto. Okay, so for this SIA lab, okay, when we want to work on the SIA query lab, okay,
Okay.
what we will do, we will come to all the routers and we will increase the hello timer. Okay, by
Okay.
default if we'll check here, so IP EIGRP interface detail F0 by 0. So you can see here my hello timer is how much? 15 second, right?
Five.
Yes,
5
hello is
seconds.
5 and hold is 15 seconds, right?
Yes.
Okay, so we will be increasing the uh, our hold timer, right? Okay, I think we are using
Okay.
old so version. Okay, 12.4. Okay, no problem, let's increase it. So we'll come here conf t, better to use new router. Okay, let me use new router 15.0 something. Okay, so here we have added a new version of the routers, you can check here. Okay, so version 15.4. okay, and now we are enabling, we'll check here, so IP interface brief exclude unassigned, yes, interface is okay. Check here also, R2 interface is okay, R3 interface is okay. Now let's come here and enable routing. Router EIGRP 10 network. So we just wanted to have EIGRP routing. That's why now come here conf t router EIGRP 10 network no auto. Save it. Neighborship is up. And now what we in this lab, first thing in this SIA lab, first thing what we are going to do here when we are checking here, so IP EIGRP interface detail E0 by 0. So you can check here that our hello is 5 and hold is 15 and SIA timer is
Yes.
180 seconds, right?
Okay.
Okay, so that's why we are going to increase the hello timer. So come here conf t interface E0 by 0 and then we'll type here IP hold time. We are going to increase hold time. Hello is okay 5. Hold time of EIGRP 10 is 300 seconds. We are going to increase up to 300 seconds. Exit. Same thing we will do with this neighbor R2. Conf t interface E0 by 0. Exit. And then interface E0 by 1 and then exit. Come here to R3 as well. Conf t interface E0 slash 1 and then exit and then come here and check verify. Yes, it is 300 second now, right? Okay.
Yes.
Now after that what we'll do, we'll enable some access list on R3 to check SIA query packets. Okay. So before that, now what we are going to do, we'll come to R2 and we will enable some query debugging. Okay. So we'll come to R2
Okay.
and we'll say here debug EIGRP packets query, okay, and update two things. Now come here, uh, show history. Let's copy this to R2 and same thing we will enable on R3. Debug query and update. Okay, fine. Now same thing what we will do, we'll come here, right click and we will capture this. Okay.
Okay.
To capture we will be using same means like Wireshark as well and EA. Okay. So Wireshark, why we use Wireshark? Because Wireshark will give you more details. Okay.
Oh, yes.
Okay. So Wireshark is there. Now let's come here to R2 and sorry R3 and enable ACL. Okay. Access list 100. Okay. Before access list, let me show you something here. If we type here, so IP route EIGRP, yes, you are getting one, right? Here also
Yes.
everything is okay, stable network like that. Okay.
Okay.
We'll just come here, conf t access list 100 deny EIGRP from any source to any destination, means you want to block EIGRP packets. Okay.
Okay.
Any and then access list 100 permit IP from any source to any destination. Okay. And then we are going to enable this access list. So we'll come here to interface okay, P0/1, okay, then IP access group 100 inside, and then exit. Okay, now we will come here to R1. Okay, and in R1, if you'll check here, so IP route, you have one. Okay, this one. Okay, and if you check here, so IP route, so IP EIGRP topology, one is there, right? Okay, and it is
Yes.
P successor, right? Can you see here, only
Okay.
single successor, no feasible successor, right? And if this
Yes.
network is down, so if you put making down to that network, you have to come here conf t interface loopback one shut, right? Shutdown manual.
Okay.
Okay, and then C in topology table, what is saying that it is active, right?
Yes.
Okay, and see the timer is running now and waiting for reply
Remaining
from my
12.
neighbor, right?
Okay.
Same here R2. See what happened. R2 hasn't received any query packet. Okay. So IP EIGRP topology, yes, it is active. Query has been sent to neighbor. Okay, and if you check here in this EIGRP query, oh, I did mistake. Okay,
Okay.
you know what mistake? The earlier lab was okay because when I added a new router, okay, in the new system of the routers, they have resolved the SIA query problems. Okay,
Okay.
okay, so when okay, no problem. What we can do? Uh, let's use the old router again. Okay,
Okay.
okay. So see here, what we did. Uh, we have the old version of router again. So
Yes.
version 12.4, and in that we have enabled the this one, the hold a timer on all the routers up to 300
Yes.
seconds. Okay, and what we are going to do, we'll come to R2 conf, conf t here, sorry, debug debug EIGRP packets query and update. Two things, query and update, no about hello. Okay, otherwise we will have a lot
Okay.
of information. So history, let's copy this two message from R2 and R2. Okay, now what we will do, we'll configure some ACL to block some EIGRP messages so we can see the
Okay.
query packet and the stuck inactive messages. Okay, we'll come to R3
Okay.
and we'll type here conf t access list 100 deny EIGRP any and any, means block EIGRP messages, and then access list 100 permit IP any. Okay, fine, and then we'll apply on the interface. So interface FA0/1 IP access group 100 in, and then exit. Okay, and then we'll come, remember I told you that we have to enable Wireshark, right? So what we'll do, we
Yes.
will enable Wireshark on this interface. Okay, right click, start capture here. So your EIGRP hello message is running. Now what we will do, we'll come here and to R1, and then we'll say that, see if you check here, so IP EIGRP topology. Okay, so see, one is active now, sorry, one is passive now.
Yes.
And what I will do here, conf t
Yes.
interface loopback 1 shut down, and then we check here, see in topology once it is shut down. Okay, can you see here?
Okay.
Okay, and talking about query, why we are not getting query message? Query, debug query, and then see here, he received some query, right? Who is sending?
Yes.
Okay, received query, sent query, query asking. Okay, so neighbor has sent him some query, no problem. Again what we will do, conf t interface loopback 1
No shit.
no shut, query will stop. Then again we'll come here, conf t interface loopback 1, and then we'll see here, let's remove this query. Okay, no shut, sorry, shut down, and then you will check here, it is in active state, right? Remaining from reply from
Yes.
R2. Okay, R2 has received some query here, see here, right? Okay,
Yes.
and why R3 is not receiving any query? Because of ACL, right? ACL is applied here, that's
Okay.
why R3 is not receiving
Okay.
any kind
Yes.
of query message. Okay, so when R3, see what is happening, R1 said that I lost connection of this. R1 sent query to R2 to work on this. R2 sent to R3, but R3 is not responding back, right, to R2. So that's why R2 is also not responding back to R1, right?
Okay.
R2 is only responding back to R1, saying that yes, I am working on your query. Are you understanding? R2 is saying to
Yes.
R1 that I am working on your query, but R3 is not responding to R3 for any kind of message, right? Okay,
Okay.
and if you come here on all, let me stop it. Okay, and now after, see here if you are checking here, so IP EIGRP neighbor, yes, see neighbor is there, right? But
Yes.
after 180 seconds, right, when R3 will not respond back to R2, you will see that neighborship will go down. You see here, let's
Yes.
we'll
I
see.
told him already.
Yes, still this guy is in active state, still R2 is also, see here, topology, where's topology, see here, R2 is saying, see, SIA stuck. SIA stuck for whom?
Yes.
SIA stuck for one peer, means one neighbor,
Okay.
means R3 is not replying me, but R1 is not in SIA stuck. See, R1 has received update query message from R2, that's why R1 has only kept this network as active, but SIA is not there. Can you see here? Okay, now
Yes.
see, 3
Yes.
minutes is about to here. Now see, after 3 minutes you can see here, neighbor has gone down, right?
Yes.
Okay, neighbor has gone down, and now if you check here, so EIP, this in topology, see, one, now one is not there, and if you check
Yes.
here in the neighbor topology, okay, this neighbor will go off. Okay, after 180 seconds, the neighbor ship has flapped, and after 300 seconds it will go off, because I have enabled 300 seconds as a hold down timer, right? So after 300
Okay.
seconds, if R3 will not reply anything to R2, it will go off from here. And see here, R1 will also remove this active state from his topology. So like this it works, okay. But in the new version of the routers it is faster. And if you check here,
Okay.
query packet, do we have any? All is hello, hello, read, hello, query, hello. See here, query packet. Who sent query packet? 12.1.1.2 has queried, and now you will see here, okay. In this query, see here, query packet, right? Okay.
Okay.
And in that query packet, it was asking about this alternate route, that asking for
One
the
on one.
neighbor,
Yes.
say, okay, please, do anyone know about this network? Okay. So
Okay.
like this it will be there in your network, okay. And and this will be, see, like what I'm saying here, we can see about some kind of, I have enabled 300-second timer, right? But this network neighborship flapping will be there always due to SIA problem, right? Okay.
Yes.
Now understand the situation. R1 said that, okay, do anyone know about this network? Okay, to R2. R2 asked to R3. Okay, but now understand one thing. Okay, see, before, when you will enable EIGRP neighborship, right? R3 has
Yes.
updated to R2 that yes, I have something, I have 23 network. R2 has updated already to R1 that yes, I have two connected networks, 12 and 23, right?
Okay.
Then why R1 is asking again about this network? Because see, you have to understand this one. R2 has already shared about that yes, what I have, and if something
Yes.
is down, then why R1 is asking this information to R2?
Okay.
Okay. So to remove these type of problems, okay, you have some solution which is known as EIGR. Solution of EIGRP stuck in active is known as EIGRP stub routing.
Stop.
Yes. Okay. So in this stub routing, or sorry, the solution, we have three solution. One is EIGRP manual IP route summarization. If you will enable EIGRP route summarization, yes, SIA query will be there, okay, but the reply will be very faster, okay. Then
Okay.
second one is EIGRP stub, or you should use
Last version.
latest version. So see, right now, if you'll talk about some organizations are very old organizations, right? You'll find
Yes.
some, like some old routers. Sometimes you'll find 12 or 12.4 version also, 12.1 also, right?
Okay.
Okay, so in those networks, the people use some kind of technology like EIGRP stub or something like that. Okay, so here we will be talking
Okay.
about EIGRP stub routing.
Okay.
Okay, that what is EIGRP stub routing? So see, we have to understand what is EIGRP stub routing. In this EIGRP stub routing, how it works, like see, this is a hub router, right? See, middle, this is the middle router, right?
Okay.
Okay, this middle router is connected with some branch routers, no problem, okay, with the help of EIGRP. Here also they are connected with some branch routers. Okay, here I can understand if this 4.4.4 network is down, I can understand that this router is asking some alternate route from here, maybe from here, right? I understand it.
Okay.
But
Yes.
if this router is connected with edge end router, like last router of your network, okay,
Okay.
then what is the need of, because see, I can ask any network is down to this router. Why? Because some routers are connected after him. I can ask from him
Yes.
because some routers are connected after him. But here,
Yeah.
do any other router is connected after him? No. Then why I am asking
No.
something from him? Why I am asking from something from him? Same here.
Okay.
Okay. So like this condition kind, like if you have some conditional lab, see, EIGRP is very simple, but all is conditional lab. Okay, if you have lab like this, how we will configure? If you have lab like this, how we have configure, right?
Okay.
Okay, so same here, if you will have lab like this, how we will be configuring it? So these labs are known as hub and spoke. Hub means you have a single router in middle and multiple routers are connected to you. Okay,
Okay.
so let's first design this lab, then we will be talking on that. Okay, EIGRP is, okay, so EIGRP hub and spoke topology. So you can understand this lab, right? R1 has this
Yes.
1, 2, 3 loopback, R2, R3,
Yeah.
R4 is your hub
Yeah.
router, and R4 has one 4.4.4.4 network. Okay, and here,
Yeah, this one is the basic configuration I know already.
yes, yes, it's simple configuration.
Okay.
So we are just taking the lab access, console access. Okay, now we'll bring this hub router here and R4 router, just one spoke router. Check here. So IP route EIGRP, nothing is running. So IP interface brief exclude unassigned. Okay, IP is there, we just have to enable routing. Okay, so for routing, what we
Okay.
can do, router EIGRP 10, no auto network 000. Okay, and then exit. So let's copy this one. We'll come here, conf. Come to R1. Okay, completed. R2, R3, R4, which is your hub router. Let's check. So IP interface brief exclude unassigned. Okay, fine. Spoke router, spoke 2 router, and spoke 3 router. Okay, all is okay now. Now we have to come to a spoke 3 and check. So IP route, yes, all routes is there. Okay. Now see, we'll come to a spoke router, and what we will do, we will enable
Okay.
some query message. Okay, debug. Okay, EIGRP packets query. Okay, query. Copy this stub one. Come to a query here also, and query here also. So if I'm coming to hub router, and if any network is down, like which network, interface loopback 1 conf t interface loopback 1 shut down. When it is shut, okay, you can see here automatically spoke has received some query regarding something from neighbor, right? query packet.
Yeah.
Here also
45.
he received some query packets. He received query and now received query. And now if we'll come to hub router and check here, so IP EIGRP topology. Okay, so it is little bit faster. Okay, so you can see here
Okay.
that your neighbor has received some query, right?
Yes.
But these type of information you do not, you want to suppress, means you you want to say that I can I can understand that hub can send query to R2, R3 and these type of networks, right? But hub router
Okay.
cannot send query to the edge router, or sorry, edge router I'm saying, the end routers of your organization. These
Okay.
are end routers. Okay, end routers of your organization. Last router. So if these are last router of your organization, why they are sending these kinds of information to them? And unnecessary they will be consuming the bandwidth regarding replying query, never ship down like that,
Yes.
right? So in that case,
Yes.
what you are going to do? So we have solution here like EIGRP stub. Okay, so let's
Okay.
enable first understand what is EIGRP stub. See here, if hub router loopback network will fail, like as what I told you now. Okay, hub router will mark this 4.4.4.4, which this 4.4.4 route as active route, right? And
Okay.
send out query packets to spoke routers for asking alternate path, same thing. However, it is obvious that if other route exists on hub router towards this network, it will send query to all its neighbor. Okay, if there is no routes, see why routers generate query packets when they do not have any feasible successor, right? No routes. That is
Yes.
why router sends the query packets to neighbors asking for the alternate path. Now,
Okay.
though the querying process is waste of bandwidth and resources, as we already know, to prevent unnecessary querying, spoke router
Okay.
in hub and spoke topology can be configured as a stub router these, so these routers, okay, we can configure them as a stub router. And see, these routers are stub and these routers are non-stub routers, right? So in EIGRP technology, non-stub routers cannot send query to stub routers, but a stub router can send query to non-stub routers. Okay,
Okay.
now, so a stub router builds a neighbor adjacency with hub router, no problem, and will inform neighbor of its stub status. And it will inform means like, see how these hub routers will know that yes, I do not have to send query here, but I can send query here, right? So hub, yeah, spoke router will inform to the hub router, yes, I am stub. Okay, please do not send query to me. So whenever hub router will generate any query, so they will send to these routers but not to these routers. Okay,
Okay.
the stub router will build the full topology table, no problem in that. Okay, neighbors will eventually stop querying the stub routers, which help EIGRP convergence quicker and save the link bandwidth as well. Okay, and we have five type of stub here. Okay, and what we can do in this stub, see, EIGRP stub routing is used to stop query message
Go.
sent from
That's it.
another non-stub router. Means non-stub router cannot send query message to a stub routers, means the last end routers.
Okay.
EIGRP stub router do not advertise routes from one EIGRP neighbor to another EIGRP neighbor, means it they do not advertise like this. Means stub router say that if I have some network like this, here, if I have some network like this, so a stub router by default it will only advertise their connected routes, not the received route what they are receiving from another neighbor. Okay,
Okay.
EIGRP queries are not sent from non-stub routers to a stub router, this we know. EIGRP stub routing is an EIGRP feature mostly designed to converge like local router resources, okay, such as memory and CPU utilization, bandwidth stability, okay. So normally, see, this situation and this condition you will find in rare case, okay. You will not find
Okay.
this kind of thing in all organizations.
So,
The stub routing feature is most commonly used in hub and spoke technology. So this stub routing is not used everywhere. It is used when you have conditional lab like hub and spoke, means single router connected with multiple branches.
okay.
Okay. And how you will know that yes, my neighbor is normal neighbor or a stub neighbor? You will, when you will type this, so IPAGRP neighbor detail, you will get it, and I'll show you here. Okay. See right now, if you are coming here to hub router, and if you are typing this command, so IPAGRP neighbor detail. Okay. See here you are not getting any kind of information regarding a stub. No information, no stuff.
Yes.
Okay, you have, yes, you have multiple neighbor, but no information regarding. Okay, now
Okay.
we'll see something here. Okay, so EIGRP stub has five feature. Okay, means if you will enable connected, means I will, EIGRP stub router will only advertise to the hub router connected networks. And normally how EIGRP works, right? In EIGRP you only advertise your connected networks, right?
Yes.
And received also. Means normally in EIGRP you say that yes, I will advertise my connected and whatever I am receiving from my another neighbor, right?
Okay.
Here, see, here if you will check this lab, R2 is advertising network connected plus received one, right? In normal EIGRP
Yes.
topology. But in
Mm.
stub
Like all
topology,
are the connected one?
yes,
Yes.
come again.
I said they will just advertise the connected network, right?
Yeah, no, you advertise connected, but in routing updates.
Yeah. Okay. Yes. Yes.
Yes,
It will
in routing updates they advertise connected plus received one.
cross the received. Yes.
Yes, but in EIGRP stub, when you advertise whatever networks,
Okay.
so when routing updates, they only advertise connected one. So
Okay.
you have some option that yes, you can only advertise connected one. You can only advertise
Okay.
summary route. You remember the summarized route? Okay, I can
Yes.
advertise some static routes. Okay, okay,
Okay.
I can advertise some redistributed. And here is received only. Received only means I can only receive, but I cannot advertise to you.
Okay.
Okay, and leak map is there, but we will, when I told you when we will work on prefix, then I will explain you. Okay,
Okay.
so it is very simple, it's not that much tough. Okay, lab. Okay, so now what we can do, we'll simply come here to our lab, conf t interface loopback one, no shut. First let me make the lab default. Okay, network is up, and we'll check here. So IP route, yes, one is there. And on router 3 and 2 and 1 we will also enable query. Okay, see, earlier we were getting query here, and now we'll enable query here. Come here, query here also, query and update both. Update, query and update. So we will see that the router which is working as a stub router, they won't be able to receive query, but they will be receiving update message. Okay,
Okay.
spoke 1, spoke 2, and spoke 3. Now you remove this, like spoke 1, Okay, here also. Okay. Now we'll come to hub router, or sorry, spoke routers, and we'll enable. Okay, and see, when we have five modes here, I forget. When we have five modes, when we will come to enable a stub, so by default
Yes.
connected and summary is advertise by default.
Okay.
Okay, so we'll come here and we'll send here router EIGRP 10. Okay, EIGRP stub. Okay, so when I will write like this, a stub means if you write a stub or you write here question mark here, you are getting connected and uh, summary. It is already
Static,
here, it is
receive.
default.
Mm.
Okay, so if I am writing EIGRP stub means it connected and summary is there, but if you want, you can write like this also and summary also like this, same thing. Okay,
Mm.
so connected stub is okay, neighborship. Okay, see, everyone has get, see, they got some information that yes, neighborship down. See, they received some update, but forget about this. Okay,
Okay.
update. Now come here conf t will come here router EIGRP 10 EIGRP stub. Here also is there. Okay, stub 3 conf t. Okay, okay. I'll enable some wires arc here. Okay, to get some EIGRP stub message. Okay, and then we'll come here router 3 or router EIGRP 10 EIGRP stub. Okay, now everything is okay now. They have informed everything. Let me remove all this query packet, received packet information, hub router R2 and R1. Just wait for this to come up. I don't know why my WhatsApp is taking long time to come.
Uh, Maybe you did not shut your computer like last time.
No problem. What I will do, I will update or maybe I will install and uninstall it. I don't know why.
Okay.
Okay. Spoke 1. See, hub router E0 by 2 to spoke 1. EIGRP hello is
Yes.
going, no problem. Right? And see, in this EIGRP hello message, I can show you here. See here. Um, EIGRP hello message. Who sent this hello message? 4452. Okay, see here. They will be informing about tier stub information. See, so my edge router, sorry, like the end routers, okay, the spoke routers are advertising and
Okay.
informing to the hub router that my friend, I am a stub router. Okay,
Yes.
and see, by default stub is connected and summary is advertised. Okay,
Yes.
so like now, okay, can minimize it, and we can get this information via this command also. If you will come to hub router, okay, neighbor detail. Now see who is the stub. See, our hub router have two, how many neighbor, five neighbor, r2 r3. Okay,
Yes.
and then spoke 1 spoke 2 spoke 3. See, by default connected summary is advertised and stub, and these two routers are not stub, right?
Yes.
Okay, so now see what is happening. If interface loopback 1 is shut down, conf t interface loopback 1 is shut. Okay, see here, hub router, okay, received update, but do you think that they received query? No query. Okay, but
Okay.
R3 and they will receiving query. Okay, I don't know,
Okay.
only one packet query, query. Okay, but see on this link, the link what you have enabled, on this link you will never see any query packet. See, no query packet, only hello is going, and in the last you have sent some update. Okay,
Yes.
update will be there. See, hub router. Okay, update. You have sent update. Okay, our hub router has sent update, and they have replied as hello, but no query, right?
Yes.
Okay, again let me come here to hub router. Okay, and then conf t interface loopback 1. Okay, no shut. Then see, again they will be receiving update. Okay, they will be receiving update. Okay, but no query. See, received update. Okay, again if the hub router will come here and say shut down. Okay, shut, and see, R3 has received query. See, R3 received query, R2 received query. Okay, R1 has received query. See here, but spoke, they will say spokes are not receiving any query, they are receiving update. Okay, no query. So like this you can stop these kinds of uh, problems in your organization. Okay,
Okay.
now one question will come that, okay, if you have some other network connected here, so now if you have something, see here, R4 have some, so IP interface brief exclude unassigned. So R4 has some networks, right?
Yes.
So R4 has said, R4 is like something is there like IP route 00000054.1.1.1. Some network is there, some default routes. Okay,
Okay.
now it is connected to a spoke 1. A spoke 1 says there, so IP route. See, a spoke 1 do not have 5 information, right? 5 is not there, right? So they will configure
No.
something like that. Okay, IP route is 5.5.5.5. Sorry, 255.255.255.255. Connected via 54.1.1.2, and now checking the routing table. Yes, uh, 555. What happened? 54 interface is not there. Okay, no, let me check the interface detail first. So IP interface brief exclude unassigned. Okay, you have only two interface, 45 and 10 loopback. No problem. Enable that interface. Interface E0/1 IP address 54.1.1.1 252. No shut, and then save it, and then check. So show IP route. Yes, 5 is there, right? In your routing table. See, spoke have 5,
Yes.
but if you come to other routers like hub to check here, so IP route. See, 5 is not there. See, 5 is not there. If you are coming to R1 also to check, so IP route EIGRP. See, 5 is not there. So if
No.
these, see, they all are branch routers, right? If these branch routers
Yes.
R1 wants to reach this R4 5, so spoke 1 has to advertise like this. See, spoke 1 have to come here like the conf t router EIGRP 10 EIGRP stub. You have to say connected and connected summary and then static. Okay, and you have to advertise like this. It will re-summarize. Okay, and then you will see here R1. Now check. Okay, after some time you will check that 5 will be here now. spoke. Okay, hub router conft interface loopback 1 no shut, and then let me remove all this all, remove this all debugging options. All. Okay, and see one problem. If you are coming here, see R1 is not receiving that 5, right?
Mm.
Okay, any
Yes.
idea? Even I also forget the problem. Okay, to explain, you see,
Okay.
this spoke one is EIGRP and R4 is a static, right? So a static cannot come
Okay.
directly to your EIGRP. So what you have to do, you have to redistribute where? On spoke one router, right?
Okay.
Yes, so you have to come here, conf t router EIGRP 10. Okay, redistribute static. Okay, then metric for like 10, 10, those all 5 elements. Okay, so EIGRP, this mat you have redistributed, and once you will redistribute, you will see that your 5 will come here. See, 5 is coming
Okay.
here. So it's just part of practice that how normally people use this connected summary and static.
But all those problems, if you are using this one, if you are using this one, the new version like
Yes, new in
15.4,
new version,
15.2,
stub
you will
problem
not
is not there.
face this kind of problem. Mm.
Sorry, stubs. I'm saying stocking an active problem is not there, but still you can use
Okay.
the stub in any type of conditions.
Yes.
Yes. And then after this lab, we have default route propagation in EIGRP. This is normal. Okay, I'm still working on this lab. It's not completed. Okay,
Okay.
so once it will be done, I can complete this one anytime. Okay,
Okay.
or maybe like tomorrow. I think tomorrow will be the last one. I don't want to skip anything. Okay,
Good.
and after tomorrow, we will be working on OSPF. Okay,
Okay.
okay then.
Recipe is gonna take like 1 weekend.
For OSPF, yes, yes. If the class will be regular,
Okay. So maybe by the end of this February we can finish with OSPF.
yes, yes. We will be finishing OSPF and we will be moving to, yeah, OSPF.
BGP.
Yeah, and we will be moving to BGP.
Mhm.